Hello, and welcome to the very first episode of the Chillax Cast. And as you can see in front of me is an ocean or a body of water. It's the ocean, I'll give you that spoiler. In this series, I hope to explain some of the things better known to us in the scientific community, as well as, just having you to chill out. If you want to just use this to fall asleep, that's fine. If you want to just watch as we explore the cosmos, you're more than welcome to do that as well. In this series, we will explore things such as chemistry, physics. We're going to go on a bit of a journey of education of biology together because I do not know that much biology. We're also going to do astronomy, things like that. I'm currently using Space Engine right now, and if you want to support this game, it's absolutely free. It's more of an interactive simulation rather than a game. But if you want to support this, please by all means go support it. It's free. I'll have links in the description. They're at $45,000 of the $80,000 goal. So the game, it has reached its milestone to getting completed. I believe it's just one man working on the project right now. It might have changed since I last heard. But if the more money that gets seeded into this project, the more content will be added, obviously. In fact, it will turn into a giant game, a real game, if enough money is raised. And you can look at all that and more by just simply clicking on the money bar at on the home page. But yeah, any proceeds or anything that you would donate to us in this series and everything like that, I asked, go support them. This game is what we'll be using for the most part. I'm an avid fan of simulations as well, so for this cast we might also do a little bit of flight simulation, everything like that. Very calm things that don't require a lot of stress, but very interesting things nonetheless, if you so happen to want to do that. But yeah, right now what we're doing is we're going to go ahead and start our vertical slice of the sciences by just exploring the Earth around us. Now, of course, we are on planet Earth, and it's a pretty cloudy day. We happen to be right off the coast looking at the Atlantic of Florida, but let's go ahead and just start exploring, shall we? Get right into it. As Carl Sagan once said, the cosmos is all that is, and all that ever was, and all that ever will be. And I think that's a very reasonably fair and accurate statement, even given the recent conjectures that there may be multiple universes and everything like there. All of which, by the way, is untested. I like to make it clear. I give string theorists the majority of the benefit of the doubt, but it falls into philosophy, and it's beautiful mathematics and beautiful philosophy, obviously. But there's no, we haven't been able to test these things. And if you can't test it and create reproducible data, it's not necessarily science. So it's important for us to have great imagination. But it's also important for us to have great amounts of speculation. And as you can see, this Earth isn't really high detailed in this game, but we can kind of make things out as we travel across, going at about 1 kilometer a second. We see nothing but lush green, and of course that's because we're in Florida, and it's a very swampy region. It's very, crocodiles. I've never been to Florida. I'd like to go. Definitely visit the Kennedy Space Center on Cape Canaveral. That'd be amazingly. That would be quite the trip. Actually, that's honestly why I started us right there on the coast. Is I actually started us somewhere in the region of Cape Canaveral because exactly just as the shuttle launches from there, I would like us to start our journey into the cosmos from there. And let's go ahead and speed things up a bit. Keep us going down this path, wherever we're going, I don't know. I have no sense of direction right now, so it's anyone's guess, really. Yeah, here it is. The music in this game is I think wonderfully done. It's great. Just this whole thing. Like I love using this, and we're going a little high there. Don't want to go there yet, but you know what? Let's screw it. Let's start exploring the universe, shall we? So let's just go on up. And come on up. And there we are. Here we are. Let's go ahead and stop. Just take a look. There's Earth. There's our cloudy day. It's very cloudy out there. So let's go ahead and zoom out. Let's get away from these clouds. Let's go ahead and go somewhere where there's no clouds at all. Take a look at our home. This is home. Everyone you've ever known, loved, cared for, everyone you ever read about, everyone. They all lived out their lives here, including you. In fact, if we do it just right, which I am clearly not, but if we were to navigate it just right, we could wind up in my little home in Pennsylvania. Of course, it's not doing that. We'd have to use something like Earth. I don't know. Well, let's look around. This is just the beginning. There's our Milky Way. There's the main. There's our sun, Sol. Let's see if we can get to the moon. That's Venus. Star. Mercury. There's our moon. Start traveling towards it, shall we? We're now going 179 kilometers a second. That's far faster than anything we've really sent out there. Let's see here. Let's go a little faster. Of course, I could be wrong. We might have sent something, a probe or something, a lot faster, but definitely not any manned spaceship. Not that fast. Yeah, believe it or not, it takes a very long time to get to the moon going this slow. If we were to go the speed of light, it would take us only about a second. Up there, it's coming up on it real quick, so let's go ahead and slow down. Now, of course, right now, what we have here is we can't really see it, but we're at the back side is facing us, the Earth, or the front side. The side that faces Earth is tidally locked, so the same side is always facing us. And if we go around to the other side, though, we see that the moon is literally littered with craters. Craters upon craters of asteroid impacts, comet impacts. And the reason why is because it's kind of acted sort of as a shield for us, like a line of last defense, as it were, but heavily bombarded. On this side, not so much, but definitely there are some bombardments there. And as we will find out, the universe doesn't really care. It doesn't really take aim. It's just shooting in the dark, really. And every so often, shooting in the dark happens to hit us. Let's go. Oop, we just landed on the surface. Too bad we can't see anything, right? Let's get up there. That's home. That's us. That's home. Let's see if we can. Let's go further still. Let's go to Mars. Let's take a trip out to Mars. 1.27 astronomical units away. If you were to go to the speed of light, it would take about 20 minutes to get there. 20 minutes. Now, of course, it's many people say that it's the closest candidate to us being able to inhabit it, and that's a long shot, given that it's quite cold on the surface, and its atmosphere is mostly carbon dioxide, argon, and nitrogen molecules, which is very thin, mind you. It's not entirely gone, but there isn't as strong of an atmosphere there. But there is one. It's got about a third of the gravity as Earth. It's a beautiful, beautiful red planet. It's called Mars, as it was named after the Roman god of war, god Mars. Might have been believed back then that this was his home, this was his turf, and it wouldn't be too surprising given that many areas around, including Greek and Middle Eastern and Roman and everything like that, they were often associated with tracts of land, especially in the Middle East. Middle Eastern religions, pre-Christianity and pre-modern Judaism, were very much associated with tracts of land, in fact, but that's neither here nor there. Beautiful planet. And recently we discovered water on it. It's now official. There is water on Mars, which I think is just astounding. It's amazing. And we will explore why. I mean, the short answer is that where there's water, you're likely to find life, or it's possible to find life. So there's also other candidates in the solar system which clearly have water, and they have ice buried beneath their sheets. The red planet, of course, none of the planets are really in that high detail in the space engine when it comes to our solar system, but we will see much, much better images when we go out into the cosmos and explore. But this is it. This is Mars. And if we were to go ahead and just, I don't think my arrow is on right now, so we can't really see Earth, but I can give us an example of it. Let's go ahead. Let's just see. I believe one of these might be Earth right here. Okay, we'll turn it on orbit to see if that works. That does not work. So let's go ahead and turn it off. Can't see Earth. Now let's go ahead and take a look at some of its moons, shall we? Ooh! Careful. Of course, it's orbiting at a very high velocity. I think we've seen enough of this series, which is located inside the asteroid belt. Go ahead and take a look at that. Nice and calm. Let the void take you, as we will soon be stepping out into it. We'll leave the comfort of our solar system. It's part of the asteroid belt. It's a dwarf planet. Almost as a dwarf-led. I don't know if they've actually confirmed it. I mean, in this it has, but and a lot of people have a lot of resentment that Pluto got knocked into it, but he's happier there, as Neil deGrasse Tyson says it. There's many dwarf planets out there. Otherwise, Pluto would be one of the most loneliest, smallest planets that we have. He's a dwarf planet. There are little dwarf planets that are bigger than Pluto out there. So the idea that Pluto is large, or is a planet, I don't know. I don't fall into either one of the camps. I call it a dwarf planet because that's what nomenclature says I should call it. And I am not one way or the other. It's still a very interesting place, and we will visit it before we leave our solar system. And if I can get a hold of the images, we'll definitely take some of the first high-resolution images we're taking of the planet. It's very beautiful, very gorgeous. So let's go ahead and continue on here with the Jovian system. Of course, I'm talking about Jupiter, one of the largest planet in our solar system, or at least the largest known planet. There's talk of a giant planet orbiting our sun, way out in the darkness, and we've figured out how to find it. And if it is out there, we'll find it in the next 2 years. Here we go. Let's see if we can't see. Well, let's see. It's a little red spot is not in view right now. A storm that's been raging on for centuries. Very gutted. There's many moons, and we will explore them in this series. We will definitely go there and learn all about them, as well as about the gas planet itself. Right now, I'm just trying to take us on a trip to show us the scale of ourselves. Now, that said, we should probably continue on if we want to get into it. Or we can just stay here all day. I don't know. It's up to you. It doesn't matter. This is just a pilot episode. Things may be changed, and definitely things are going to need to be readjusted and everything like that. I may need to change my tone, or things may just be a little too boring. It doesn't matter. Here's one of my favorite planets. I think it's one of many people's favorite planets, and for little rings. And these rings are not rings at all, but millions and millions of particles, ice and meteoroid and everything like that, that's kind of just orbiting around. And it's slowly eroding, very slowly but surely it is eroding, and we'll get into that at some point. But let's go ahead and get closer and see it like this. There we go. You can start to see it. All these little particles. See, it's all just a bunch of little particles. And the game does a really good job representing that. It's probably one of the better things that I've seen represented in a space simulator, so to speak. Let's go ahead and see. There's our sun. There it is. Let's just fall through. You can see the shadow of the moons on Saturn casting its little solar eclipse. If we look back at this way, one of the most historic photos in history was taken, and I will definitely try and have the speech and the photos edited into this video. Tribute goes to Carl Sagan and he wanted to take a snapshot of Earth looking back from Saturn. And the pale blue dot is probably one of the most awe-inspiring things. In fact, the line I said earlier, everyone you ever knew, everyone, that line comes from that exact speech. And it's definitely one of the most awe-inspiring things. It's pretty amazing, and it definitely humbles you. And there is a horn in the background. I don't know if you guys heard that. I guess I better start driving, huh? People are honking at me already. Okay, let's go ahead and take a trip. Now, because I don't have the pointer and I'm not willing to stop the recording, we're just going to have to kind of do it this way for now. I wanted us to navigate it by ourselves, but I don't want us to be here all day, and I don't want to just try, so we're just going to go to Uranus. And, you can crack as many jokes as you want. I tend to pronounce it Uranus because, the joke Uranus. Any fans of Futurama out there will know that there's a great joke about your rectum, because they had to get rid of the Uranus joke. But yeah, here it is. Hydrogen, helium, and of course the ever-present methane. Yeah, it's beautiful. Look at that. But I think it's just this greeny gray thing, and it doesn't look as good in this game, but whenever we get high-res images of it, it's an astounding sight, and I'll definitely try and insert them at some point here. I'm gonna be crediting NASA about 90% of the time in the series, if you haven't already guessed. Let's go ahead and head off to Neptune. And of course, we'll all get into orbital mechanics. We're going to do a bit of math and chemistry and astronomy and physics in this series. So don't worry. We're going to do a little bit of algebra, a little bit of geometry, some trigonometry, of course, that kind of goes with it. In fact, it'll be. I would say that we'll do more trigonometry than we'll do geometry, obviously, but. More importantly, we're also going to do a little bit of calculus, and don't worry, I'll have links to tools and resources you can use to kind of sharpen your edge, your skills in math, just so you can follow along if you want, or if you would rather not. I'll just give you quick disclaimers or whatever, and you can go ahead and skip ahead in the video, or just stop watching the video entirely. It's entirely up to you. This series is not meant to be popular or to bring in views. It's meant for those who want to be here, and I think that's what I'm going to do with it. So here's our little Neptune, and this is the last of the gas giants. It's an ice giant, frozen ice giant, and of course this brings us towards the end. Now if we look back, where's our sun? It's hard to find our sun because it's very, very, very there it is. It's getting smaller and smaller, and in fact, in reality, it would be even smaller than this if you were at Neptune or our next destination, Pluto. Let's go ahead and go there. It's 27 astronomical units away. I don't know the exact distance, to be honest, but here's our little highly accurate, actually. It's very highly accurate, and I believe they actually might have taken the map, they might have taken the images, and they might have actually mapped out Pluto with the recent update. I definitely can't remember off the top of my head, so we're going to have to take a look with those images. There we go. There's Pluto's moon, Charon. And there's also a little asteroid that Xenix also orbits it. And I think we'll go ahead and try it. I don't think we can find it. Charon. Oh, I think I was wrong. That happens a lot with weather. It's a star. If we increase our speed, we should find something, right? Let's go ahead and get rid of this. Now, of course, there are other rocky bodies that we will explore as we get closer and closer towards the end. But for now, I think this is a good stepping off stone. Okay, yeah, I can't find it. Oh, well. More for next time, right? Nope. We do not want to go there. I do not want that. There we go. Okay. And of course, these other bodies will, who might make Eris. We'll go after all of those later. And of course, I'm going to go ahead and see if I can't find the images for Pluto and put them up here. It's very gorgeous, but for now, let's just take one last look at our solar system. Earth is somewhere in there. Somewhere. It's almost as you couldn't make it out if you tried. It's just another dot A series of dots, if you could see it. There you go. There's our star. There's the solar system. But let's go ahead and say farewell as we step out into the void. It's beautiful. Gorgeous. As you can see, we're just slowly making our way, increasing our speed ever so much. Now, right now I'm going a little faster than the speed of light. And if I were to continue to do this for about 4 years, if I were to hold my finger right here on this key for about 4 years, I would reach the nearest star. However, we're not going to do that. We're going to go a little bit faster than that. And we're going to go ahead and increase our speed. So we leave around, we pass through the Oort cloud, which I don't think is simulated in this game. If it is, I'm not very aware of it. Past further and further still. The sun gets smaller and smaller. And it just becomes another blip. A series of blips. We're closing in on about a light year away. For those of you who don't know, is the time it takes for light to travel in 1 year. To get here, roughly, it takes about a year. It takes light about a year to get here. So light that you would see from, say, planet Earth would reach this point right here, in the middle of smack dab nowhere, in about a year. Let's go ahead and increase that. Let's travel at a light year a second now. Sun's just another blip now. What's that star? There's the sun. Pricon. Canis Minoris. Ooh, Alabor. Very Arabic name. Let's keep going, shall we? Altair. Let's go ahead and take a quick look at Altair, shall we? It's a white subgiant. This simulator claims it has 9 planets orbiting it. Let's go look at it. And as we close in, closer and closer and closer still. Wow, it's very, very luminous. That's for sure. Well, let's take a look at this. This is a cold ice world. Its temperature is negative 145 degrees Celsius. So we'll round that up to 146. It has a greenhouse effect of about 3.8 degrees Celsius. It has 11 moons. Very, very strange world, but indeed definitely large. Oh, wow. Well, we didn't come all this way for nothing. In the background, you can see the large Magellanic Cloud. And we'll go ahead and take a look at that before we end this episode. We'll step out into the cosmos on the grandest scale, which is yet to come. And if you're using this to fall asleep, I hope that the music is ambient enough for you. Well, you know what, if you don't like it, I guess you could just close the window. That solves that problem altogether, right? I don't know if I'm going to have guests on the show later or not. I'm not too sure. It's just all just a work in progress, and that's okay, because it's kind of how I wanted this to be. It's a hodgepodge. It's nothing special, nothing unique. It's recorded, it's edited, it's thrown up, and if you like it, you like it. If you don't, you don't. Want to see a frozen world? Here it is. And as you can see, it's not doing too bad, but not too good. Frame rate. Let's get up a little bit. There we go. And there's our star Altair. Those of you from the Assassin's Creed series will know Altair means eagle in Arabic. So, little fun trivia fact for you, if it is even a fact. I remember reading that somewhere. I have not confirmed that, so I could be completely wrong. I could be making shit up. I don't know. You need to check me. You need to double check everything. And it's always an important rule of thumb is to question everything. No matter who said it, just question it. Dig up the answers for yourself, because you will find, often we make mistakes or we outright lie, and it's important for you to be able to discover and figure those things out, and relatively quickly. I myself being guilty of having done that before, and now of course I wasn't trying to ruin anyone's lives, but there are people out there who would do you harm with that. They would deliberately hurt you, and they would screw you over in ways that you can't even imagine. Ooh, look at that ring system. Most of the time it's for money. That's usually what it is. It's all about money for a lot of people. But, oh wow, look at that. That moon is scarily close. That is a very scarily close. Now, of course, this one's even scarier, but the size of this one and the orbit it's taken, wow, it's quite the sight. But let's go ahead and take a look at what a planet would look like. What it would look like. There, and there's... Wow, look at that. Just... If this doesn't get you excited about the universe, I don't know what will. Just the idea. Maybe finding planets with life, which we definitely will look for in the future. For now, we're gonna take a really large step out into the universe, and we're gonna go ahead and go farther than, well, we've ever gone before. A lot of people say, why is it so bright this way? And this is because the solar system isn't the center of the Milky Way. It's in the suburbs of the Milky Way, as it were. We're towards the end of it. We're towards the edge of the galaxy. And we're going to go ahead and see that here. We're going to start traveling. Now, of course, if we traveled at 11 light years a second, it would still take us quite a while to get to our center. In order to get there, we're going to have to speed things up drastically. And remember, every dot that we are passing by is a star. It is a star with its own planetoids, its own systems, perhaps life around it. Some of the stars are ginormous and gigantic, and we're definitely going to take a look at some of these huge, massive stars that when they die, they'll explode their enriched guts everywhere out into the universe. And the leftovers would be a neutron star or a black hole. We'll look at those too, and what it's like to, I guess, we'll fall in. Of course, lots of speculation beyond that point. We don't know. There's a lot of things. In fact, some theories have come out that say black holes don't even exist. Some have come out that say there's firewalls behind a black hole, so you're immediately vaporized the moment you cross the event horizon. Kind of ordeal. As we get closer and closer to the center, you can see as we pass through these clouds of dust and gas that we're starting to see a higher and higher concentration of gas. There we're starting to see star clusters form, and star clusters are massive swaths of clusters of stars, millions, thousands to millions of stars bound together by gravity. At the center of them sometimes is usually a black hole, I believe. We're going to definitely take a look at that. But as we get closer, just note the huge amount of star density as we get closer and closer. And we start seeing more and more clusters as we get closer to the center. And every galaxy is now believed to have a supermassive black hole. We definitely have one in here. Wow. There's a dark little smattering. Let's just click on that. That's a diffuse nebula. Whew. Isn't this something? Just seems scary as we just keep traveling towards the light, so to speak. But it's just out there, and it's wicked and creepy. And sometimes I get creeped out by space, the infinite void of it. Every galaxy out there, on average, there's millions and millions of stars and billions. Our galaxy is on the order of a rough low estimate would be about 2 billion stars. It's beautiful, isn't it? And look at all the star density, all these stars, each and every one of them. We're out there somewhere. We're back out that way somewhere. Let's go ahead and go towards this globular cluster. Take a look at it. This is towards the outside rim of our galaxy, which will take us to the next section where we're going to start exploring the cosmos on the grandest of scales. And we'll see how our galaxy is just an island amidst billions of other islands in a sea of nothingness. Look back. See everything. And at the center of this galaxy, look at this. There's something here. SBC. Go ahead and zoom out. That's the center, by the way, that we were just looking at. And there's our galaxy. We're out here somewhere. And out here you can see these other little dots. And you're like, what are those? Those are galaxies. Let's come back here for a second. Take it in. There's the great galaxy M31 Andromeda. One of our closest larger neighbors. We have 2 smaller neighbors orbiting us right now. The large Magellanic Cloud, and right up here the small Magellanic Cloud. We're going to go ahead and take a look at the large Magellanic Cloud and work our way to the small one, out to Andromeda. Right now we're going thousands of light years a second. It's important to note that if we wanted to cross from one end of our Milky Way to the other, we would go a light year a second. It would take 100,000 seconds to get from one end to the other. So we're just falling into this giant dome of gas and dust. Of course, tons of stars. Galaxy Andromeda. And there's another diffuse nebula. There's the small Magellanic Cloud right behind it. And I think we'll just go ahead and go over there and we'll take a look at what it would be like to live on a planet inside the small Magellanic Cloud. Cluster of diffuse nebula. Whew, we're going too fast. I think you'll be a good candidate. It's a binary blue main sequence star system, so it should be good. go to the cool desert, shall we? There's our two parent stars. Oh wow, it's way out there. There it is. So, depending on where your orbit was during the year, looking out at the clouds. Over to the night side. At night, you can see something spectacular. You might have a more humble view of where your origins are. There's the large monumemt cloud. There's volcanism on this. Just go ahead and see what's on the volcano, shall we? Go to this mountaintop and just look at it. Just sit and imagine if you were an inhabitant on this planet and you just happen to live in this little valley right here. Live in this little valley. That was your view every night. The large Magellanic Cloud right there. The Milky Way. And you might be at first believe that they're the same size, but in reality the Milky Way is orders of magnitude larger. That's just beautiful. And I think with that, we're going to take a quick look at how big and how small we really are in this cosmos. Let's not forget, Earth is somewhere on the edge of somewhere in here. And you could not even make out the star that we live on. You couldn't even make out the group that we live with. Where's our M31? Where's our closest neighbor? These galaxies are known to be a part of the local group inside the Virgo supercluster. Vast ocean of galaxies. Now, of course, the universe may be infinite. We don't know. But it seems to go on forever, and it sort of does. In this simulation, it kind of goes on forever. It eventually stops. And we'll take a look at some of the oldest galaxies that we know of. And we'll go ahead and look for Earth here. Let's go ahead and go home, shall we? 9 billion light years away. there's home. You don't feel small yet? I certainly do. Well, I think that'll be it for the first episode. I hope you enjoyed spending time. If you would like to check out this game for yourself, definitely links will be left in the description